Well, hello guys and welcome to the Chem channel. Today I am going to discuss a very important numerical problem in which you have to calculate the theoretical yield and percent yield, and after discussing and solving this problem you will be able to find the theoretical yield and the percent yield in every problem and every numerical problem you are given. So let's start discussing our numerical problem. And the numerical says that heating 24.8 gram of copper carbonate in a crucible produced only 13.9 gram of copper oxide. Here you can see the copper oxide is the product of this reaction, and we have already told that 13.9 gram of copper oxide is produced, which is the actual or experimental yield of this reaction. Now what the question asks for is what is the percent yield of this copper oxide. Now according to this question we have to calculate the percent yield of the copper oxide in this reaction. Now in the solution you can see that the given data is the amount of copper carbonate which is available, and it is equal to 24.8 gram, and that of actual or experimental yield is equal to 13.9 gram. Now the required data is we have to calculate the percent yield of the copper oxide. Now we know that the formula of the percent yield is given by actual yield divided by theoretical yield multiplied by 100. Now if we look at the question again, so you can see that in the available data the actual or experimental yield is available, while we are required to calculate the percent yield. So according to this formula of the percent yield, the actual yield is available while the theoretical yield is unavailable, or we can say that we have to calculate the theoretical yield, and then after finding the value of theoretical yield we will put all the values in this formula and we will calculate the value of the percent yield. So let's first discuss the balanced chemical reaction in which there is a ratio between copper carbonate and copper oxide is 1:1. So you can see that here in this reaction if 1 mole of copper carbonate decomposes, it will produce 1 mole of the copper oxide. If 2 moles of the copper carbonate decomposes, it will produce 2 moles of the copper oxide. So this is what the balanced chemical reaction tells us. And now let me show you the second page on which we will have to calculate the molecular weights of the copper carbonate and that of the copper oxide. So here you can see that the molecular weight of the copper carbonate is equal to 64 AMU is that for copper atom, 12 for that for carbon atom, and 48 for oxygen atom, because we know that the atomic mass of the oxygen is 16 AMU, but here we have 3 oxygen atoms, so that's why we multiply it by 3 and we get 48, and then we add up all these 3 values and we get 124 gram of copper carbonate. Now let's calculate the molecular weight of the copper oxide. Again the atomic mass of the copper is 64 AMU while that of oxygen is 16, so when we add up these 2 values we get 80 gram. Now according to the balanced chemical reaction, after we have calculated the molecular weights of the copper carbonate and copper oxide, we know that and we can see that 1 mole of copper carbonate is equivalent to 1 mole of the copper oxide. Now what does it mean is when you decompose 1 mole of copper carbonate you will get 1 mole of the copper oxide. Now we know that 1 mole of the copper carbonate is equal to 124 gram of copper carbonate, and 1 mole of the copper oxide is equal to 80 gram of the copper oxide. Now we divide both sides by 124, and why we do that? Just because I want to establish a conversion factor in which 1 gram of the copper carbonate is equal to 0.66 gram of copper oxide. So when you divide both sides by 124, here you can see that you get this value. Now we multiply both sides by 24.8 gram, and this is the available amount of the copper carbonate. So let's see how much amount of copper carbonate which is available produces the amount of copper oxide. So we will multiply these both sides by 24.8 gram, and when we multiply these both sides by 24, we get 16.38 gram of the copper oxide. So here you can see that the 24.8 gram of copper carbonate produces 16.38 gram of copper oxide, and this is the theoretical yield of this reaction. And you get the theoretical yield of the reaction by doing some mathematical treatment of the balanced chemical reaction, while you obtain the experimental yield after treating it practically. When you do the experiment practically and you obtain the yield, this kind of yield is called actual or experimental yield, which is available in this case. Now let me show you the third page, because we have calculated the theoretical yield, and now we simply have to calculate the percent yield. So the formula of the percent yield is equal to actual yield divided by theoretical yield multiplied by 100. Now we have the value of actual yield is equal to 13.9 gram, and that of theoretical yield is equal to 16.38 gram, and we multiply it by 100, and we get 0.86 multiplied by 100, and when we multiply these two values, we get 86.87%. This is the answer to this question, and this is the percent yield of this reaction. You can see that 0.86 multiplied by 100, which is equal to 86.87%, and this is the, you can see the percent yield of this reaction. If you find out this video helpful to understand some of the basic concepts of chemistry, then don't forget to subscribe my channel. Thank you for watching, and see you in the next class.